Okay guys, so this would be part 1 ng conceptual lectures natin for aircraft design, stability, and control. So this part would focus on stability, no? So how an aircraft would respond when disturbed from equilibrium. Okay, so first is why stability matters. I know you guys know kasi this is a review na lang eh. We've already done the equations, we've already studied yung iba't ibang design features, yung mga sizing ng structures and etc. But again, we have to fully understand no why stability matters. So again, on flight, no, your aircraft isn't flying on a perfect condition or a perfectly calm environment. So throughout your flight, um, yung aircraft natin, it would experience, yun nga, disturbances such as turbulence, gust, thermal currents, pati mga wind shears. Additionally, yung pilot natin, they can also change yung power settings and yung mga control. So, all of those, yung disturbances, pati yung iba't ibang control, they tend to push the aircraft away from the equilibrium. So, if you want an aircraft that is well-designed, we would want a stable aircraft, no? A stable aircraft would respond dun sa mga disturbances na yun in a predictable manner. So ideally, it would either return to its original condition, no? Sa equilibrium, or it would move towards a new condition where yung piloto natin would not be exerting too much effort. Okay? So, yun. So next, axis of an aircraft. So, yun nga, to understand more yung stability natin, we first need to understand how the aircraft moves. So, yung aircraft natin, it rotates about 3 imaginary axes, no? So, yung mga axis na yun, perpendicular sila sa isa't isa, no? Familiar naman na kayo doon, no? We have the longitudinal axis, yung axis from the nose to tail, and then you have the second axis, no? Yung lateral axis, yung wingtip to wingtip. Tapos, you have yung third vertical axis, no? Passing vertically through the center of gravity. So, yung whenever yung aircraft natin experiences a change in attitude or behavior or in movement, yun nga, yung aircraft natin would rotate about one or more of these axes. Okay? So, yung rotational motions that we have on those axes are, yun nga, yung roll, pitch, at yung yaw. So, let's start with yung sa wait lang. Yeah, longitudinal axis, yung roll. Okay? So, sa longitudinal axis, again, it extends from nose to tail ng aircraft natin, no? And then, yung motion or yung rotation about this axis, yun nga, is roll. So, pag yung aircraft natin nagbabank ng left to right, yun nga, it is rolling about its longitudinal axis. Okay? Take note yung wording natin na rotation, motion, tas yung word na about. So, pag about yung gamit natin, it's our primarily focusing on the rotation. Okay? If it's along, there's a different motion. Okay? Again, pag ang usapan is motion about, we're mainly talking about the rotation sa axis na yun. So, again, yung motion about the longitudinal axis is yung roll. So, yung primary control surface natin responsible for the roll would be yung aileron. So, what else? Yung roll natin, no? It is essential siya for turning yung flight natin. Tama? Kasi in order for the aircraft to turn, kailangan mag-bank muna yung aircraft. So, yun. Okay, yung aileron natin yung nagpapabank or nagpaparoll dun sa aircraft natin. Okay, so when sige, yan lang. Okay, So next is yung sa lateral axis. Okay? So yung sa lateral axis naman natin, yung axis na yun, it extends from again one wingtip to wingtip. Okay? And yung motion or rotation about this axis is called yung pitch. Okay? Yung pitch natin yung nagde-determine whether yung aircraft natin would yung aircraft's nose natin would move upward or downward. Okay? Yung pitch natin, again, it's primarily achieved by using the elevators. Tama? So, actually, among all the rotations, no, yung pitch roll tsaka yaw, yung pitch natin is generally considered yung most critical kasi this affects yung angle of attack, and in flight performances, angle of attack affects a lot of the aerodynamics ng ating eroplano. Okay? Kasi a change in angle of attack would influence yung ating lift, yung drag, yung airspeed, yung climb rate, yung stall characteristics. Okay? So, yung pitching na to, yun nga, it has a strong influence on the overall aircraft behavior. Okay? That's why, by the way, going back here sa longitudinal axis, yung roll, again, yung motion about the longitudinal axis would be roll, but for rolling, ang tinatarget na stability ng rolling is the lateral stability. Okay? So, when we refer to the stability along the longitudinal axis, we're mainly talking about the rolling motion. Dito naman sa lateral axis natin, again, motion about the lateral axis would be pitching, but yung stability would be longitudinal. Yung pitching natin would be focusing on the longitudinal stability. Its motion would be on the lateral axis, about the lateral axis. So next, we have yung vertical axis. So yung vertical axis natin, again, it passes through the center of gravity, okay, and perpendicular siya with the other axis. So yung rotation about this axis is called yung yaw. Yung yaw natin occurs when the aircraft's nose move from left to right. Okay, what controls the yaw? It's the rudder. So yung yaw control natin is essential for, ayun nga, making coordinated turns, or pag may crosswind tayo, it can correct yung ating stability. And then yung tawag natin for control niya is directional control. And like I said, yung rotation about the vertical axis would be yaw. Yung stability na ginagawa ng yaw would be directional stability. Okay? So, yun. Next, moment and moment arm. So, another important concept natin for aircraft stability, yung moments, no? So, if you recall, a force acting on an aircraft does not simply move the aircraft. Kasi if the force acts away from the center of the gravity, it can also cause a rotation dun sa aircraft. Tama? And yung rotation na yun, we call that the moment. Okay? The magnitude of the moment is determined by two factors. No? That's the force itself and yung distance from the center of gravity where the force acts. That would create our moment equation. Okay? So again here, yung M natin represents moment, F represents force, and then yung D represents the moment arm. Notice that even a small force can generate a large amount of moment, especially if that force acts far from the center of gravity. Okay, so this principle explains why yung tail surfaces natin, they can generate powerful stabilizing effects, even though yung force they produce are relatively small because of the arm, yung moment natin is strong. So their power to rotate the aircraft is strong. So the tails are considered one of the most important part ng aircraft natin for stabilizing the aircraft. Kasi even though again, onti lang yung force na i-exert nyo for the tail, it could create a huge moment for the whole aircraft. So moments acting on an aircraft. So yun nga, several forces act simultaneously on a aircraft. You have yung lift, no, which acts primarily through the wings, and then yung weight acts through the center of the gravity. Yung thrust natin is generated by the engine or the propulsion system. And then yung drag natin, this opposes the aircraft's motion. And then finally, something na hindi main force but for stability purposes, yun nga, we have to talk about a lot about the force contribution ng ating tail. So yun nga, the tail generates additional aerodynamic forces. So each of these forces, no, they may create moments around the center of gravity. So aircraft designers, they attempt to arrange these forces so that yung mga moment nila, they balance, no, under normal flight conditions. Kasi a properly balanced aircraft would require minimal control input. Okay, so that would exhibit a more favorable stability characteristic. Okay. Moments acting on an aircraft ay nakalimutan ko palito yung title but should be yung sa tail force natin. Okay. So the horizontal tail natin, no, again, it's one of the most important stability device on an aircraft kasi again, it's the primary tool for balancing the aircraft longitudinally. Okay? So yung mga aircraft natin, most conventional aircrafts, they are designed dito with the center of gravity ahead of the wings. Tama? So naturally, yung arrangement na yun, it would create a natural nose down tendency. So to counteract yung tendency na yun na mag nose down yung aircraft, we have yung horizontal stabilizers, no, at the tail to produce a downward aerodynamic force. So because this force acts far from the center of gravity, again, it would create a balancing nose up moment naman. Tama? So if by design, if your center of gravity is ahead of the aerodynamic center, nose down ng aircraft. So yung design ng tail natin, it tends to produce a downward aerodynamic force that would counter yung nose down, no? So yung result would be a stable equilibrium. Okay? So next, aircraft design characteristics. Aircraft design characteristics. Take note na for every aircraft, no, they would feel very different to fly. For example, you have a Cessna trainer, meron kayong Airbus A320, meron kayong F-16. All of those, they may obey the same aerodynamic principles, but pag nag-input na talaga yung piloto, they might respond differently. Okay? Yung difference na yun arises from three fundamental handling qualities that we have for aircraft design. No? Stability, maneuverability, and controllability. So these three, they are closely related to each other, but they are not the same thing. No? Yung aircraft natin, they may be highly stable but not very maneuverable. An aircraft may be extremely maneuverable but require constant pilot correction. So the designers must find the appropriate balance depending on the mission of the aircraft. Okay? So let's go over one by one itong design characteristics natin. First with the stability. Okay? So stability is defined as the inherent tendency of an aircraft to maintain or regain equilibrium after being disturbed. So the keyword here is inherent. Okay, we're not talking about what the pilot does. We're talking about what the aircraft would naturally want to do. Okay? So let's say suppose a gas causes a disturbance with the pitch ng ating aircraft. Let's say it pitches the nose upward. The question is, would the aircraft naturally try to return to its original condition, or would it continue pitching farther upward? So, yung answer natin to that question would determine whether the aircraft is stable or unstable. So, this property is again built into the aircraft during the design phase. Okay? So, ang makaka-apekto doon would be yung wing location, tail size, yung location ng center of gravity, or even the overall geometry ng ating aircraft. So therefore, again, stability is primarily a design characteristic rather than a pilot or an input characteristic. It's inherent to the design. Okay? So, more on stability, we have two major categories for stability. Okay, so we divide it into two concepts. First would be static stability. So, yung sa static stability natin, it asks what is the aircraft's initial response immediately after disturbance. Okay? For dynamic stability naman, it asks what happens to the aircraft over time upon being disturbed. Okay? So, think of yung static stability as the first reaction. Tapos think of the dynamic stability as the entire story. Okay? So again, an aircraft may initially move back towards equilibrium. That would indicate a positive static stability. However, if upon returning to the equilibrium, yung oscillations natin, they grow larger with time, you wouldn't call it dynamically stable. Okay? Kasi if it doesn't go back to the equilibrium over time, it has negative dynamic stability. Okay? So therefore, both of this, they must be analyzed independently. So first, let's examine yung first three forms ng static stability. You have yung positive static stability. Ito yung kapag upon being disturbed, yung aircraft natin, it immediately tends to move back toward the equilibrium. So for example, if yung nose natin is pushed upward, yung aerodynamic forces natin on the aircraft, inherent to the aircraft, would generate a restoring moment. That would lower yung nose natin. And yung neutral static naman is upon being disturbed, yung aircraft natin would remain in the new condition. No restoring forces would exist. Okay? Wala ring destabilizing force that would exert more force to push out yung ating equilibrium. Okay? Yung aircraft natin, it would simply stay where it is displaced. Okay? And then finally, you have yung negative static stability. Meaning, yung disturbance natin, it continuously grows. Okay? So let's say if the nose rises slightly, it would continue rising even further. Okay? The aircraft moves away from the equilibrium. Okay? That's negative static stability. It's evident on this figure right here. Okay? Next, dynamic stability. Again, let's consider naman what happens after yung initial response. So imagine pulling an aircraft slightly nose up, okay, and then releasing yung control. What would happen is yung aircraft natin, it may begin oscillating, So the important question would be, what happens to the oscillation over time? If yung oscillation natin, it becomes smaller and eventually disappears back into the equilibrium, yung aircraft natin, it has a positive dynamic stability. If yung oscillation natin remains constant, yung aircraft natin, it exhibits neutral dynamic stability. And if yung oscillations natin, they become larger, yung aircraft natin would have a negative dynamic stability. So this concept is extremely important because passengers yung passenger natin yung nakakaramdam talaga ng kaganapan na to eh. Okay? Yung passengers natin, they do not feel static stability. That's inherent to the design of the aircraft. But itong dynamic stability, this may be felt by the passengers kasi this is over time. Okay? Yung passengers natin, they would feel whether the oscillations are damping out or they are continuing. Okay? So, interpreting yung curves that we have here, yung first curve natin, again, itong kulay dilaw, it shows yung oscillation natin decreasing with time. Yung energy natin, it's gradually dissipated back into the equilibrium. This is called yung positive dynamic stability. Next would be the second curve, yung ating kulay green. So for this one, no damping exists. You would see na yung oscillations natin, they remain constant. And then finally, yung third curve natin, yung pula, this shows oscillations increasing over time. No? Each cycle, it shows a larger peak than the previous one. This is negative static. This is negative dynamic stability. Okay? So next, we've covered now yung positive, negative, and neutral static and dynamic stability. Let's move naman sa tackling longitudinal stability. So among all forms of stability, yung longitudinal stability natin is usually considered the most important one. Okay? So longitudinal stability refers to the stability about what axis. So if it's asking the stability about what axis, that's the lateral axis. Okay? But if it's asking motion or rotation about the lateral axis, that would be pitching. Okay? So, in simpler terms, it governs yung longitudinal stability natin, it governs pitching motion. Okay? So, if an aircraft lacks longitudinal stability, yung aircraft natin, they may enter yung steep climb or steep dive or mag-i-stall yung aircraft natin or yun nga, mahirap sila kontrolin. Okay? Because yung pitch natin, it directly affects yung angle of attack natin, which again affects yung lift, drag, pati yung mga stall behavior natin. So for this reason, yung aircraft designs natin, we devote enormous effort into achieving a great longitudinal stability. That's why for most stability studies, longitudinal stability talaga yung pinaka-main na inaaral. So factors affecting longitudinal stability, we have three primary factors. First is yung wing position. Second is yung horizontal tail position. And then third is yung tail size. Okay? All of this would affect yung moment natin that is acting around the CG. Okay? So more concepts now for aircraft stability. For most conventional aircrafts natin, they are designed with yung center of gravity ahead ng center of lift. Okay? This arrangement, again, intentionally creates a nose-heavy aircraft. At first glance, it would seem na undesirable yun, kasi ba't nose down? Why would the designer intentionally create an aircraft that is nose-heavy? The answer is stability. Okay? Kasi a nose-heavy aircraft would naturally tend towards a safe recovery behavior. Okay? So, to balance yung nose heaviness natin, yung horizontal stabilizer natin at the back, they create a downward force. Okay? Because yung tail natin is far behind the CG, even a relative small downward force can create a substantial balancing moment. Okay? So next, Okay, how does longitudinal stability works? Pasok tayo sa physics dito, no? So, pag yung aircraft natin, it slows down, no? Yung wing downwash natin, it decreases. And pag nag-decrease yung downwash natin, yung downward force natin sa horizontal stabilizer, it also decreases. Okay? So, yung nose heavy tendency natin sa harap, it becomes stronger kasi mas humina yung downward force natin sa likod. So, what would happen is the nose begins to drop. And pag nag-drop naman yung nose natin, yung airspeed natin, it would increase. Okay? So, as airspeed increases, yung downwash natin would increase again. Tapos pag nag-increase yung downwash, yung tail natin, yung stabilizers natin, would generate more downward force. So what would happen to the nose is it would rise again. No? So, by design, yung aircraft natin naturally seeks a new equilibrium condition. Notice na walang input yung pilot na ginawa. So, inherently, by design, nung nose heavy characteristic natin and yung restoring balance ng tail natin, inherently, they naturally seek an equilibrium. Okay? That's the good thing about designing an aircraft like that. It must have positive static stability. Okay? So, yung aircraft natin, itself, on its own, it would generate restoring moments. No? So, that's the essence ng ating longitudinal stability. So, more about the longitudinal stability. So, you have yung effect ng thrust line. Okay? So, yung longitudinal stability natin, it's not only influenced by the lift and yung tail forces natin. It can also be influenced by the thrust. So, yung location ng thrust line natin relative to the center of gravity, it affects yung pitching moments natin. If yung thrust line natin is above the center of gravity, if we increase the power, it would tend to generate a nose down moment. Okay? This is called yung high thrust line configuration. If yung thrust line naman natin, it passes below the CG, if we increase the power, it would generate a nose up moment. Okay? Ito yung principle natin kung bakit meron tayong positive and negative ZT. Okay? So, designers natin, engineers, must carefully position yung propulsion system natin to avoid undesirable pitch changes during power adjustment. Kasi again, it would affect, it would contribute pitching moments. Depende kung saan yung thrust line natin. Okay? So, that's pretty much for the concepts natin for longitudinal stability. There's more, but more can be explained by the equations na inaaral natin. So, let's move to the conceptual ng lateral stability. So, lateral stability. So, everything we've discussed so far focused dun sa pitch stability, tama? So, we will now move sa roll stability. Dito, ang ginagamit mostly for lateral stability focuses sa geometry features ng aircraft natin, such as yung dihedral, yung sweep back, yung wing placements, yun yung mga kill effects. Okay? Kasi for longitudinal stability, we focuses mostly on moments, lift drag forces, weight and lift forces, But for lateral stability, most of it is affected by the geometry of the aircraft itself and the wing itself. Okay? So, let's go over one, dihedral. So, the dihedral effect or the dihedral of the aircraft or the wing rather, is probably one of the most recognizable contributor to lateral stability. No? Yung dihedral natin refers to the upward inclination ng wings natin relative to the horizontal plane. So many Gen Av aircrafts, they have noticeable dihedral angles. No? Kasi they create stability. So imagine if yung aircraft natin experiences a disturbance, yung sa pag nagsa-side slip yung aircraft natin, yung relative wind natin is now approaching from the side. Tama? Approaching from the side na siya. So, because of the wing geometry, yung lower wing natin, no, it would experience a larger effective angle than the higher wing. No? So, consequently, yung lower wing natin, it would produce more lift. And yung upper wing natin, it would produce less lift. Okay? This is kapag may dihedral tayo. Okay? So, yung difference in lift, it would generate a restoring rolling moment. Yun yung kagandahan ng dihedral natin. No? It changes yung relative angle of attack natin, especially during side slip. Okay, so again, yung lower wing natin, it produces more lift. Yung upper wing natin, it produces less lift. So, yung difference in lift would create a restoring rolling moment. Okay? So, yung aircraft would begin rolling back toward level flight. That's the main purpose ng ating dihedral effect. Okay? So, next would be yung sweep back effect. So, another major contributor is to lateral stability is yung wing sweep back. Yung swept wing natin, yung leading edge niya, it angles rearward rather than remaining perpendicular to the fuselage. Yun yung swept wings, swept back wings. Okay? Yung stabilizing mechanism ng sweep back effect is like the dihedral, it's apparent during a side slip. Okay? So imagine if yung aircraft natin is slide slipping to the right. Yung right wing natin would experience airflow that is more perpendicular to the leading edge. No? So what would happen is it would increase yung effective velocity, no, on that wing. So the result is syempre increased velocity on that wing, increased lift, no, on the lower wing. So meanwhile, yung opposite wing natin, no, it would experience reduced lift. So again, the difference in lift production would create a restoring rolling moment. Okay? And by the way, an interesting rule of thumb, no, that is frequently cited is if we have a 10-degree swept back wing, that is equivalently equal to the effect ng 1 degree effective dihedral. Okay, they provide an effect similar to each other. Okay, so you can either do a dihedral wing with a 1 degree or a swept back wing with a 10 degree. They would create the same lift difference during side slip. So this is one of the reasons why swept wing aircrafts can achieve adequate lateral stability without requiring large physical dihedral angles. Kasi again, they have the same effect, especially on side slips. So next, we also have yung kill effect and weight distributions. So another important contributor, no, yung kill effect. To understand yung sa kill effect, this is more apparent, no, sa mga aircrafts like sailboat. Yung kill natin, no, it maintains a directional orientation by interacting with the surrounding fluid. So, sa mga aircraft, yung portions natin of the fuselage above the center of gravity, no, it would create yung kill effect na sinasabi natin. Okay? This is particularly evident sa high wing natin. Ang nangyayari is para tayong nagkakaroon ng pendulum-like effect, no? Pag yung kill natin is high wing, imagine parang nagpe-pendulum yung ating aircraft. So, pag yung high-wing aircraft natin, it enters again as side slip, no, yung aerodynamic force natin acting on the fuselage tend to generate restoring moments because of the pendulum effect. Okay? At the same time, um, yung fuselage natin, no, which kasi nag-hang siya below the wing structure eh. So pag may side slip tayo, dito, parang kinokontra niya yung side slip. So what would happen is, again, may pendulum-like effect tayo. Yung fuselage natin, it would go back, no, into equilibrium during side slip because of the pendulum effect. Kasi yung keel natin or the main lateral like structure natin is at the very top. Again, magkakaroon tayo ng pendulum-like effect. Okay? So the combination ng keel effect natin and yung pendulum effect nga, it makes high-wing aircrafts naturally more laterally stable, no, than low-wing configuration. Kasi again, once may side slip tayo because of the weight ng fuselage natin hanging on the high wing, it would just try to go back like a pendulum. Okay? So, we're done with lateral stability. Next, we consider yung directional stability. So, directional stability refers to the stability about what axis? The vertical axis. Okay? In simpler terms, it concerns yung aircraft's tendency natin to maintain its heading direction. So, yun. Okay? This is, again, para lang mas maganda yung directional control natin sa aircraft. We must take into consideration also yung directional stability. Okay? This is yung way of aligning yung aircraft natin with the wind, no? With the incoming wind. Let's say if yung gas natin, if a gas causes yung nose natin to yaw away to the relative wind, if we want a directional stable aircraft, yung aerodynamic forces natin should generate a restoring moment that would realign yung aircraft natin to the relative wind. Okay? So, the primary component responsible para sa behavior na to would be yung vertical stabilizers natin. So, more on vertical stabilizers, no? Let's say, again, yung consider natin yung aircraft natin is flying straight ahead. A gust pushes the tail to one side. So, pag pinush yung tail on one side, that would cause a yaw motion. So, as the aircraft yaws, yung airflow natin, it would strike yung side ng vertical stabilizer. So, pag nag-strike siya sa side ng vertical stabilizer, yung magkakaroon tayo ng pressure, no, that would develop on one side of the fin. So, yung pressure na yun, it would create a restoring moment about the center of gravity. Okay? So, yun. I think na-discuss to sa inyo sa yung side slip sa basic heli ata, no? Yung mga slipstream, yung mga ganun. Okay? So, if yung vertical tail natin has a larger tail surface, it would tend to create a stronger restoring tendency. Okay? So, yung sweep back pala, it also affects directional stability. Okay? Although yung vertical stabilizer natin is the primary contributor natin para sa directional stability, yung wings natin, geometry ng wings, can also contribute. So again, yung sweep back natin, it plays a role. So imagine yung aircraft natin, it yaws slightly to the right. Yung left wing natin would become the advancing wing, no? Yung right wing natin, it becomes the retreating wing. Because of the advancing wing, yung wing na yon, it would experience a greater airflow velocity, no? It would also develop greater drag. So yung drag imbalance na yon, it would create a restoring yawing moment. Okay? So yung advancing wing natin is effectively pulled backward. So that would align again the aircraft to the relative wind. Okay? This is because of the sweep. Okay? Although yung effect ng sweep is relatively small compared sa vertical tail tsaka stabilizers, it still assists, no, sa directional stability natin. So next, we arrived, no, sa one of the most famous dito, term or stability phenomena sa aircraft design, which is the Dutch roll, no? Ang Dutch roll natin is an oscillation involving both roll and yaw motion. Tama? It's essentially yung aircraft natin simultaneously it oscillates laterally tsaka directionally, no? If you would look at this motion head-on, yung nose natin, it traces a figure 8 motion, no? It traces a figure 8 pattern. Again, this phenomenon occurs because yung lateral and directional stability natin, they are interacting with each other. Each of them are trying to go back, no? And by doing that, it affects the other directional stability, no? It affects the lateral stability. So as the aircraft attempts not to, let's say, correct a yaw disturbance, yung corrective action, it would produce a rolling motion, no? Yung rolling motion naman yun, it would generate another yawing motion. So the cycle repeats, no? So ang result nun, an oscillatory motion, no, that can be uncomfortable, no, or potentially hazardous if not maintained by the pilot. Okay? So yun yung Dutch roll. Okay? So next, finally, we have yung sa spiral instability, another phenomenon, no? It's another important lateral directional stability phenomenon. Pero unlike yung Dutch roll natin, which is oscillatory, ang spiral instability natin is usually slow and progressive. Okay? Yung aircraft natin, it gradually enters an increasing bank, no? And a descending turn. So, yun, no? Yung instability natin, it develops when yung directional stability natin is stronger than the lateral restoring tendency. So, ang nangyayari is nagkakaroon tayo ng side slip, no? Yung directional stability natin, it yaws the aircraft into the relative wind. Yung yaw na yun, it would cause one wing to move faster than the other. If that happens, yung faster wing natin, it generates more lift. So, yung bank angle nag-i-increase. Pag nag-increase yung bank angle natin, the aircraft would begin turning more steeply, no? Pag nangyari yun, ang nangyari is, pag nag-bank siya steeply, it would it would turn very tightly. That would tend to push yung aircraft downward. Okay? So imagine if nag-bank siya to the left or to the right, no? Mostly to the, maybe to the, anong location to? To the left. Pag masyadong malakas yung pag-bank niya, it would dive yung ating aircraft. And if that happens, yung aircraft natin would or can enter a spiral. Okay? Yung spiral instability. So, that's pretty much it for part 1, no, ng aircraft design, stability, and control. Mainly, nag-focus tayo sa stability concepts natin. For part 2, we will tackle yung iba't ibang control inputs, tsaka ano yung mga nagko-control sa mga napag-usapan nating motions. Okay? We'll also tackle yung mga devices, no? Yung mga flight controls. So, yeah.